Good day, class. Our topic is all about the square root. Okay, so we have here the definition for the square root. It is, or the square root y of a number x, or any number x is a number that is multiplied by itself to give the original number x. Okay, so for the symbol for square root is like this. Okay, so we have here the vinculum and the division sign. For example, for you to further understand what square root means, if we have here the square root of 4, it is equal to positive and negative 2. Since 2 times 2 being multiplied by itself gives us the product of 4, same way when we multiply negative 2 by itself. Negative 2 times negative 2, it is also 4. So again, the square root of 4 of our y here is the number x, or is the number 2 that is multiplied by itself to give us the original number, which is 4. Okay, so again, the square root of 4 is positive and negative 2. Thus, we can say the square root of 4 is positive and negative 2. Okay, so let's move on to the second one, which we call the perfect square. It is a number that can be written as a product of two equal integers. Okay, examples of which are 9 and 25. They are considered perfect squares. 9 is considered perfect square since 9 is equal to the product of the positive 3 times 3, or 3 in itself, also negative 3 times negative 3. Okay, so again, a perfect square is a number that can be written as a product of two equal or the same integers. So as you can see here, we have the same integer, which is 3. Okay, when multiplied to itself, the product is 9. Same way with the negative. Also, 25, since 25 is equal, or the factors of 25 are 5 and itself, or 5 times 5. Also, negative 5 times negative 5 is also equal to 25. Therefore, perfect squares, or examples of perfect squares, are 9 and 25. Third, we have what we call the principal root. This time, it can be called also as the principal square root. It's the positive square root of a real number. Remember that when we discussed earlier what square root means, okay, we got an example of both a positive and a negative number. Okay, but this time, if it's only the positive square root, okay, we are referring to its principal root or principal square root. Examples: the principal square roots of 4, 25, and 36 are 2, 5, and 6 respectively. Okay, so again, these are the positive square roots. So when we multiply 2 by itself, we got 4 as the product. Okay, also 5 by itself, the product is 25, and 6 times 6, it's 36. Okay, we have here the principal since we are only referring to the positive. Okay, and when we try to plot these square roots in the number line, okay, we have here the square root of 4 is 2, therefore we can plot it around here. The square root of 25 is 5. It's still on the right of the number line. And lastly, the square root of 36, or the principal root of 36, is 6. Here it is. Okay, so for the last, this time it's not always we get the perfect square or the principal roots perfectly. Okay, so if we have, for example, a square root which is not rational, or meaning to say it's irrational since it's non-terminating or non-repeating, okay? So to estimate the principal square root of a given number, we get the two perfect squares closest to the given number. And we estimate as a principal square root to be between the principal roots of the two perfect squares. Okay, so we have here an example for you to visualize it. For instance, we have to estimate square root of 17. We all know that square root of 17 is not a perfect square. Okay, so here we have to find the two perfect squares closest to 17. And to do that, okay, we can find it by knowing that it is between the principal roots of 4 and 5. Since 4 squared, or 4 times 4, is equal to 16, and 16 is a perfect square. Okay? And 5 squared, or 5 times 5, is 25, which is also a perfect square. So meaning to say the square root of 17 is between the square root of 16 and 25. Okay? So here, and then we have to subtract our given radicand, or our given number, to the perfect squares that we got. Okay, so we have 17 minus 16 is equal to 1, and 25 minus 17, the radicand, is equal to 8. Why do we need to subtract them? So that we would know later when we plot it on our number line, which is square root of 70 more closer to. We know that it is between 4 and 5, but we don't know yet, okay, which it should be closer to. Is it closer to 4 or is it closer to 5? That's why we subtracted, okay, the radicand, or our given number here, to the perfect squares closest to it. So to plot the square root of, or the principal square root of 17, here on our number line, it is between 4 and 5. So it is somewhere here. And as we can see here on the difference of the radicand and the principal squares, the smaller one is this one, 1, which is, okay, meaning to say 4. Square root of 17 is closer to 4 than 5. Or, if you do not want to subtract it, you can just look at square root of 17. Is it closer to square root of 16 or square root of 25? Of course, square root of 16. Okay? So, if we try to plot that, it is between or closer to 4. So, somewhere here. But it doesn't touch 4 since it's not a perfect square. Okay? So, when we label that, it's square root of 17. It lies around here. Find the square root of these two. And for letter B, find the principal root, meaning to say the positive square root, then plot it on the number line. Thank you for listening.